Number 5 is a shadow problem. So they start out by giving us this picture of a man walking toward a building. His shadow is displayed over here, and the distance from the light to the building is 100 feet, and he's 6 feet tall. So they give us that information. And they say that he's walking away from the light and toward the building at 4 feet per second. So that is dx. If we're going to call this x, him walking, how fast is he walking, x, dx dt is 4 feet per second. So we write that rate down. It wants to know how fast is the shadow on the building becoming shorter. So isn't that dy dt? When he's 40 feet from the ground, and know that this is the when, right? So you do that at the end after you take the derivative. Okay, so how do we do this? Well, we have to set up similar triangles. Usually in these shadow problems, you use similar triangles. So let's say that the height, 6 over the height of the shadow, 6 over y. So we're talking about this height to this height is equivalent to x, this distance right here, over the total distance, 100. All right, so solving for y, you get 600 over x. Now, we're going to take the derivative because we want dy dt. That's what it asks for. Dy dt would be negative 600 over x squared dx dt implicitly, because we're doing it in reference to time, which we don't have the time variable, so we have to do implicitly. So simplifying now, here this x squared is not 40 squared. When this is 40, the distance he is from the building is 40, and the total is 100. That means that it's 60 feet. The distance between the light and where he is has to be 60 feet, and that's what we set x to be. So we have to use x as 60. So when we substitute that back in, we get, and dx dt, remember, is 4. So there's like a step in between here. It was negative 600 times 4 feet per second over 60 squared. So that's where you get negative 2400 over 3600. And that simplifies to negative 2/3. So that's the answer. His shadow is moving, is getting smaller. If you say getting smaller by a rate of 2/3, or it's changing by negative 2/3. The height is changing by negative 2/3. Okay, so this next problem is about a balloon rising in the sky, and it has a camera zoomed in on it, and the camera is 200 feet from the base if you're looking straight up at the balloon. And it tells you that it's rising at a rate of 10 meters per second. Now, I said dx dt is 10. Why did I use x? Well, because in the picture, they used x here. Y is the hypotenuse and theta. So I just was trying to use the variables they gave you. So they gave you dx dt is 10. And then it asks how fast is the angle of elevation changing. So that would be d theta dt. When, okay, here's our when that we do after we take the derivative. All right, so what do we know? We want theta. So we have to have an equation for theta to take d theta, right? So let's say theta, and we know the adjacent to theta, which is 200, and we know x is what we want. So let's say that it's the tangent, tangent of theta is equal to x over 200. So we know that x over 200. So we know we can take the derivative of this. So I'm going to take the derivative first. So if I take the derivative of this side, I get secant squared theta, that's the derivative tangent, theta, d theta dt, so I should write that right, d theta dt is equal to 1 over 200 x dx dt. Just x prime, right? So dx dt. And I want d theta dt. So d theta dt is equal to 1 over 200, and then x dx dt they gave us was 10, so times 10, divided by secant squared of theta. Now, when the balloon is 150 meters high, we're going to need to find what the secant is at that time. So we're going to rewrite this now, where we know in time that this would be 150 and this would be 200. And so what would y be? Okay, so y would be, do we need it for secant? Yeah, we've got to have it for secant. So let's see, y squared equals x squared plus 200 squared. And at that time, wouldn't this be a 3, 4, 5 triangle? Because this is 3 times 50, and this is 4 times 50. So wouldn't this be 5 times 50? So that would be 250. So we have y, and now, so secant, I'm running out of room. Let's use purple or some or yellow so it shows up. I'm going to do this over here. Secant theta is 1 over cosine. And the cosine in this triangle using theta, the cosine would be 200 over 250. So we can inverse that, reciprocate it. Make a reciprocal. Switch it. 250 over 200. Okay, so that would be divide by 5, 5/4. So we get 5/4 for a secant, but it's squared. So we have so far 10 over 200, right, over 5 squared, so 25/16. So let's try to do this. 10 times 16 would be on the top, and 200 times 25 would be on the bottom. So this 10 would go away and make that a 20. And this would, 16 would go, that was a 1. The 16 would become, divide by, let's see, 4. That would be 4 and 5. And so we got 4 over 125. So that's what we would have. So theta is what they wanted, or I'm sorry, d theta dt is equal to 4 over 125 radians per second. And there you go. That's the answer to number 6. So give the homework a try, and I'll the answers are posted on the back of the homework sheet, and then I'll get some videos to show you how to do some of the homework problems.